In the previous video, we explained the theory and the production process of CNC machining. Welcome to the second episode of Craving CNC. I'm Hemi. In the last video, we briefly talked about what exactly CNC machining is. Today, we are diving into more details. We have learned that CNC is a subtractive manufacturing technology that produces a part based on a CAD model. It removes material from a blank at high speed by cutting or spinning tools which are under computer's control. All of these natures make CNC distinguished from laser, plasma, and EDM cutting. The main types of CNC machining system are milling and turning. Milling is to remove material from workpiece, which is mounted on the machine bed, while the cutting tools are rotating to cut the piece. In turning, also called lathe, it is the workpiece rotating on the chunk, and the stationary cutting tools remove material from the workpiece, reversing the process by moving the static cutting bit over the workpiece. When it comes to milling, the most common one is 3-axis CNC milling. 3-axis means the milling machine has 3 linear degrees of freedom, including X, Y, and Z axis. Axis leads to the vertical direction, Y is the horizontal direction, and Z is moving up and down. The principle of 3-axis is to cut the material from the blank, which is mounted on the machine bed. The rotational cutting tools move along X, Y, Z coordinates to cut the parts as designed, and these are typical 3-axis machined parts. However, since 3-axis machines can only cut parts along 3 axes, it is usually used for cutting parts with cubic geometries. If the part has 6 sides to machine, operator has to flip the blank and change fixtures manually. Besides, it is difficult for 3-axis to machine parts with unconventional shapes and deep, narrow cavities. If you have limited budget, or the surface of a part is the only position need to be machined, 3-axis is the best choice. And the setup time for machining is much shorter than 4-axis or 5-axis, and the processing price is much more affordable. As 3-axis are easier to program, the maintenance fee is much lower. Speaking of 4-axis, we generally understand this technique as 3+1 axis. In 4-axis, the machine also has X, Y, and Z, and adds an A axis that rotates around X, so we call it 3+1 or 3+A. 4-axis comes in a few different arrangements, but generally they are vertical machining, which means the spindle rotates around Z. Normally, a block of material is mounted on the X and rotates on the A. Therefore, 2 sides of the part can be machined in a single fixture setup. Let's take a look at this workpiece. Compared with 3 and 3+1 axis machine parts we mentioned above, this workpiece has more complex geometries. It is machined by 5-axis. 5-axis implies that 5 sides of the workpiece can be automatically machined at one time. Here are 2 main types of 5-axis: indexed 3+2 axis and continuous 5-axis. By adding C-axis rotates with Z-axis and working with X, Y, Z, and A, 3+2 starts producing parts with tight tolerance. In 3+2, the X, Y, Z, and AC rotation axes are working independently, which means the workpiece can be rotated relatively to the cutting bit to any compound angle. If you need to produce parts with deep cavities and complex structures, 3+2 can produce a part from any direction without manual rotation, making it a suitable option for you. Continuous 5-axis can not only cut flat compound angles, but also shape complex curved 3D surfaces. Generally, continuous 5-axis is being able to produce parts that are useful for me. Of course, complex designs need support from professional machines and dedicated program operators, which means the cost of 5-axis will also increase accordingly. Overall, the most appropriate manufacturing method depends on the material, production volume, budget, and geometric complexity, etc. If your parts require tighter tolerances and more complex geometries, 5-axis could be a better choice. If you just need a better and faster way to machine parts with simpler structures, then 3+2 is more accessible. Both full axis and 3+2 have unique advantages. Choosing the right techniques benefits your manufacturing process to increase your profits. There's no one-fits-all manufacturing technique. CNC has also limitations. It cannot cut an inside right angle. Even if the blade is sharp, it is impossible to cut a right angle of 90 degrees inside the product. But if you have specific requirements, EDM wire cutting can do this for you, while the cost will increase significantly as well. CNC generally produces parts with high dimensional accuracy. However, if you have tighter tolerance requirement, it means the chance of part failure will increase, so does the cost. CNC, especially 5-axis, is capable of producing parts with extremely dimensional complexity. However, due to the subtractive nature of CNC, there are some products that CNC cannot produce, such as conformal cooling channel and cylinder, curved pipes. So our recommendation is SLM metal 3D printing. Alright, that's all for the video. You're welcome to leave your comments down below if you have any suggestions. We have talked about so many CNC machining principles and applications in this video. Hope it helps. See you next time.